Alright, welcome back to Physics Math, and this is part 2 of our review of trigonometry. So, last time we talked about Sohcahtoa, which stands for sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. And these are, I'll write it out. So sine of theta equals opposite over hypotenuse. Cosine of theta is equal to adjacent over hypotenuse. And tangent of theta is equal to opposite over adjacent. So there's three other forms of three other trigonometric functions that you'll see come up in the rest of trigonometry and calculus that you should also know. So we have sine, cosine, and tangent, and we also have cosecant, secant, and cotangent. So these are similar to sine, cosine, and tangent, but they represent the inverse of this relation of sides. So I'm going to start with cosecant. So cosecant of theta is equal to, it's equivalent to sine, but instead of opposite over hypotenuse, it is hypotenuse over opposite. Hypotenuse over opposite. And you could also say this is equal to, I'll use a different color for this, 1 over sine of theta. I know it's a little backwards because you think cosecant would be associated with cosine, but that's just the naming convention that is used. Cosecant is equivalent to sine. There's probably a good reason for this naming convention, but I just remember it by thinking it's opposite of what I would think it would be. So we have cosecant of theta is hypotenuse over opposite, which is equal to 1 over sine theta. We have secant. Oops. So secant of theta is equal to, and again it's the same thing here, so instead of adjacent over hypotenuse, we have hypotenuse over adjacent. And similarly, this is equal to 1 over cosine of theta. And then lastly, the one that makes sense is cotangent. Cotangent of theta is the inverse of tangent of theta, opposite over adjacent. So in this case, it's adjacent over opposite. And this is equal to 1 over tangent of theta. And one thing to note with the way I'm describing this, I'm describing it as inverse, and I'm talking about the inverse of the fractions as opposed to the inverse function. So cosecant is not the same as inverse sine. So in a previous problem, we had, if we were trying to solve for theta, we would take the inverse sine, so sine to the negative 1, of both sides, and then the signs would cancel out. When I say inverse in this case, I'm not saying this. I'm saying inverse of the functions, or of the fraction that this is equal to. So inverse as in I'm flipping the denominator and the numerator. So just be careful with nomenclature and how you describe describe the inverse functions and then these next three trigonometric functions. And where these come into play most often in trigonometry is you might get a large equation with a bunch of these sines, cosines, and tangents, or cosecants, secants, and cotangents, or some mix of them, and the question will ask you to try to simplify it to its simplest form. And a lot of times these large equations can be simplified down to something like just cosine. So I'm going to do a couple examples of this today, and this is really going to be the focus of this particular lesson, is just word problems. And I dropped a cap somewhere. I'll find it later. So we won't use red. We'll use blue and green. And the way I'm going to do these problems is I'm going to write one up I'm going to give a couple seconds for you to pause the video and try it out yourself. If you need to watch through the first example before you feel comfortable doing that, that's fine. But I would like you to try these by yourself on a sheet of paper. I'm not going to do any crazy ones. They should each take a maximum of maybe 2 minutes. And then I want you to unpause the video and see if you got the same answer that I did. So let's start out with our first example. Let's just say cosecant of theta divided by sine of theta. And I am really making these up as I go. I don't have any planned ones, so we'll see how this turns out. Hopefully most of them will turn out nice, but you never know. So we'll see. So here I have cosecant of theta divided by sine of theta. And I know from before cosecant is the same thing as 1 over sine. So I will rewrite this as 1 over sine, and I'll stop writing the theta because the theta is implied here, just for simplicity. So 1 over sine theta times 1 over sine theta. And you can multiply this out, and you get 1 over sine squared theta. Oh, I need to stop writing out theta. Like I said I would. So 1 over sine squared theta. And then we can simplify this one more time. Since cosecant is equal to 1 over sine theta, this is the same as cosecant squared theta. And that's your answer. All right, let's try a slightly more complicated one. So in this case, we're going to do tangent of theta times secant divided by cosine. And again, I have no idea what this is going to turn out to be, so we'll give it a try, see if we can simplify it some more. So tangent of theta, I'm going to write all of these in different numbers, or different colors, just so we keep track of each. So I'm actually going to write tangent in blue, secant in green, and cosine in black. And I'm going to take a minute, so if you want to try solving this yourself, I would pause the video and just give it a try and come back. So I'm assuming you've paused the video at this point, and we're going to work through this problem. So starting off with the blue part of this, the blue tangent. In previous lectures, we mentioned that tangent is equivalent to sine divided by cosine. So I'm going to rewrite tangent as sine over cosine multiplied by secant, which previously we said secant is equivalent to 1 over cosine. So times 1 over cosine. And then we have our last piece, is all of this is divided by cosine. So here we're going to have 1 over cosine. And now we can multiply it all together. And we're left with a sine on top and 3 cosines on the bottom. So this was not a very well chosen problem. But this is going to give you sine divided by cosine cubed. And we said cosine is equivalent to 1 over cosine is equivalent to secant. So this can also be rewritten as sine times secant cubed. And again, this is sine of an angle, we normally call it theta, and secant cubed of an angle, we normally call it theta. And I'm just not drawing up the thetas here because it's implied, but if I wanted this to actually be a final answer, I would say sine of theta times secant cubed of theta. All right, let's do another problem. Let me actually think this one out so it turns out nicer than the last one. So we're going to have cotangent. We'll do times, let's see, times sine times secant divided by, we'll do tangent. And we'll figure this one out. So I'm going to split it up by color again, just so that we can see each of the pieces. So cotangent, actually I'll rewrite it with the colors. So let's see. So cotangent I'll write in blue. Sine I will write in green. Secant I will write in red. Secant. And tangent I'll keep in black. So let's start with cotangent. So in the same way that tangent is sine over cosine, cotangent is cosine over sine. So I will start by writing that out. So this is going to be cosine divided by sine times, and then the green one we don't have to change sign at all. That's times sine times secant, which we said was 1 over cosine. So secant is going to be 1 over cosine. And then this is all going to be divided by tangent, which is sine over cosine. And now I'm going to move this up to the denominator by flipping the denominator and numerator. It's the same thing as multiplying by the reciprocal of this on both the top and the bottom. And I'm going to rewrite this. So this all is going to be equal to cosine divided by sine times sine times 1 over cosine multiplied by the reciprocal of the bottom, which is cosine divided by sine. And now we can cancel quite a lot. So the sines cancel, the cosines cancel, and we are left with just cosine divided by sine. And from what we said earlier, cosine divided by sine is the same thing as cotangent. And so that is our answer to this problem. All right, we'll do one more problem, and then we'll call it a day for this video. So let's do secant squared times tangent. Let's divide that by sine cubed cosine squared. And let's do one more. Let's do cosecant. This is a bit longer of a problem, but I figured we're moving relatively fast. So this is going to be a challenge. If you want to try it by yourself, I would pause the video, just take out a scratch piece of paper, and just see how far you get. Alright, I'm going to assume that you paused the video and you tried this problem. So we're going to go ahead and go through it. So I don't have enough colors for everything, but I will do my best to split it up in different pieces based on color. So we'll do secant first, and we'll say secant is blue. So this is all going to be equal to secant squared times, we'll do tangent as green, divided by, we'll do sine cubed as red, and cosine squared, we'll do, I guess we'll do blue again. And lastly, cosecant, we will do green. And so like before, we're going to split it up, split each section up into its individual parts of sine, cosine, and tangent. or really sine and cosine, and we'll see what can cancel. So let's see, we'll probably need a new line because there's a lot of items. So starting off with secant squared. So we said secant was 1 over cosine. So this is going to equal 1 over cosine squared multiplied by tangent, we said was sine over cosine. And then we have sine cubed on the bottom times 1 over sine cubed. And then we have cosine squared on the bottom. Cosine squared. And then we have cosecant. 1 over cosecant. And we said cosecant was 1 over sine. So this is going to equal just sine on the top. Times sine. And let's see if we can cancel anything. There's not a whole lot we can cancel, but let's cancel some of it and then multiply out the rest. Sine and sine cancel with 2 of the sines here, so we're left with just sine on the bottom, because we would have sine squared over sine cubed, which would just equal 1 over sine. And then we have 2, 4, 5 cosines on the bottom. So what we're left with is 1 over cosine to the 5th for 1, 2, 3, 4, 5 times sine. And we can move these up to the numerator by using secant and cosecant, and we're left with secant to the 5th times cosecant. And that is relatively the most simple form that you can get this beast of a starting equation in. It's just secant to the 5th times cosecant. Alright, I think I will call it there, and yeah, we'll go on to part 3 next time.